To help ourselves understand this, we're going to look at an example now, another example, where we have a table showing the results of a survey in which 2,276 social media users were asked whether they have ever been offended by something they saw on social media, where we need to find the probability that a user is male given that the user was offended by something on social media. So here we've got something that's sometimes called a contingency chart, where we have our data categorized already by different options. Here we have the options that the responder is male or female, as well as the options that they were offended or not offended. And if we want to talk about the probability of getting someone that was male, given that they were offended, we're looking at a conditional probability. Something B given A, where we're going to say that B is the event that they are male, given the event that they are offended. And when we're making this conditioning, we're essentially restricting our options down to just those that were offended. So we're only going to focus on that first column yes value, which means that we're going to have a total of 1,151 options for that. We don't care about the people who weren't offended. We only want to know about those that were. And specifically, we want to know those that were offended who were male, which in this case would be 532 of the 1,151 offended respondents. Or if you want to represent this as a decimal, it would be a value of approximately 0.462. So we would have here that the probability of getting someone who is male given that they were offended is about 46%. Where it's important to notice here that looking at this value, this conditioned value, it's fairly different than what we would get if we wanted to talk about the probability of someone being male regardless of whether they were offended, which here would be 1108 out of 2276. Or for that matter, the probability of getting someone who was offended regardless of whether or not they're male, which would be 1151 out of 2276. In either case, that's not the 46% that we get here. Though, as we're moving forward, we will see that there are important cases to understand when that distinction isn't really meaningful. We're talking about things that have an effect on each other or don't, where we call those events dependent or independent, but that's what we'll get to next.